Welcome to the AP Calculus AB video for skill number 137. I can apply the product and quotient rule for finding derivatives. And the trivia question for the day is featured here is the capital of a Roman Corinthian column. And the capital of Roman Corinthian columns are easy to recognize because of this leafy figure that's carved into it. And the trivia question is, what type of plant family are we mimicking with these leafy figures typically? Alright, so this video focuses on two shortcuts that we can use for finding derivatives. And again, there's really only the definition of the derivative, and what I am teaching is shortcuts. And they're derived straight from the definition of the derivative. The first one occurs when we have a function multiplied by another function, and we want to take the derivative of that whole thing. So what we can do is we take the derivative of the first and we multiply it by the second, and then we take the first and multiply it by the derivative of the second. So this is kind of extensive notes or extensive writing. I like to shorthand it using prime notation, and what I'm saying here is the derivative of f times g is f prime g plus fg prime. So on the skill test, I'll ask you to write the rule using prime notation, and this would be basically what you should write down. You could even make it shorter if you wanted to. You could say replace the d dx of fg by just saying fg parentheses prime. Anyway, the way it gets applied is when we want to take the derivative of, right now we'll just have polynomials, and what we have is a trinomial multiplied by another trinomial. We could distribute it all out, which would be a nightmare, or we could use the product rule. And when we use the product rule, something I like doing until I get really comfortable with it is writing down which function is f, and our first function is f, and then I also write what is f prime right underneath that, and then which function is g, and our second set is g, and then I write down g prime. From there, I can write out what is f prime g plus g prime f. So I use the power rule to find those derivatives, and then I list f prime times g plus g prime times f. So you'll notice that the order I listed, g prime f, is different than up here. Remember, the multiplication doesn't change the fact that that's the same thing. So that is, was that the commutative property of multiplication? Anyway, pretty straightforward. It's just a matter of plugging and chugging. So example 2, I did very quickly. I make a note here that says avoid simplifying when possible to prevent unnecessary mistakes. If you took this whole equation and multiplied it all out through the distributive property, you would very likely start to make a mistake somewhere because you're doing so much extra algebra and arithmetic. I would avoid doing that at all times unless you absolutely have to. On the AP test, the answer we have written is acceptable. So example 2 is much shorter. We were asked to find the derivative of a binomial times a binomial, and what I did was I took the derivative of the first, which is 60, and I multiplied it by the second, and then I took the first and I multiplied it by the derivative of the second. Pretty straightforward. We'll get plenty of practice going through this through the entire year. Eventually we start to learn other derivative rules, and we'll have non-polynomials in there. We'll have trig functions and exponentials and logarithms. But the very basic is the product rule with polynomials. We can also apply the derivative to quotients, and so what I'm doing here is I'm taking the derivative of a function divided by a function. And again, there's the long way of writing it, or the shorthand. So if I wanted to take the derivative of f over g, that would be f prime g minus f g prime all over g squared. And in this instance, the order that it occurs in is much more important. We've got g in the denominator. I know some students use the expression low d high minus high d low over low low. So what that means is you multiply the low times the derivative of the high, then you subtract the high times the derivative of the low, and then you put it all over the low squared. So example 3, I walk us through that. And again, I approached example 3 in a very similar fashion, where I listed what is my f function, what is my g function, what is the f derivative, and what is the g derivative. And I encourage you to do that until you're really comfortable with finding these derivatives. Once you're comfortable in using the quotient rule, this is an unnecessary step. So our expression low d high minus high d low over low low. So the low times the derivative of the high minus high times the derivative of the low all over low squared. And again, I would encourage you not to simplify unless it's absolutely necessary. We have another instance where simplifying this derivative would become quite the nightmare. So I don't even bother doing that, and very often you don't even need to. So avoid it when possible.
The Murs only attack from beneath, trapping the fish against the surface. But they push the herring within range of the gulls. It's a feeding frenzy. The table is set for the mightiest predator of them all.
All right, let's look at one simple example of how this gets used. Very common basic level question in calculus is to write the equation of a tangent line. And so we're given the function k of x, and we see that it's a quotient, and we want to find the tangent line at x equals 1. So the first thing we should do is, in knowing that finding the tangent, what that means is we need to find the derivative of the function. So here's our function k of x. I use the quotient rule to find k prime. So there's the derivative. And we're looking for the tangent line at x equals 1. So by plugging 1 into the derivative, we can get the slope at x equals 1. So here we go. Here's the slope at x equals 1, and that simplifies down to negative 5/3. So on our curve, which, I don't know, looks something like this maybe, at 1, our slope is negative 5/3. Negative 5/3. We need to find the y-coordinate if we're going to plot this or create the equation properly. So what we can say is we have a point at x equals 1 and y equals f of 1. If you plug 1 into the original equation, you get 11/3. So we now have our point and our slope. There's our point, there's our slope, and we can plug it into the point-slope equation. And when we plug it into the point-slope equation, we get y minus 11/3 equals negative 5/3 times x minus 1. Alright, thanks for watching the video, and now you should be able to apply the product and quotient rule to finding derivatives. The trivia question was, what plant family, or more specifically I guess the genus of plants, which is commonly found at the capital of Corinthian columns, is a Mediterranean genus called the Acanthus, or Acanthus genus. There are several plants of the Acanthus genus, and they have kind of this toothy sort of leaf to them, jaggedy, toothy leaf.